Hello everyone. Welcome to SRE Summit Canada 2024. This is the workshop session. In this session, we will be talking about incident management as part of a practical SRE curriculum. Who am I? My name is Safir. I have been an SRE, DevOps, platform engineer, architect, and manager throughout my career. I have been in this domain for 18 years, and I'm an engineer, leader, speaker, and author. If you want to connect with me, this is my LinkedIn profile, Twitter handle, and my blog. And on the right side, you can see the book I wrote recently. All right, let's move on to the agenda. Now, this is a workshop, right? So, in the first part, we are going to establish the theoretical ground where we'll cover concepts and practices of incident management. It will include incident management and alert management, incident classification, the life cycle, post-incident analysis or RCA, and postmortem. Now, once we are set with the background and theoretical knowledge, we will move on to the workshop part where we have two scenarios or two questions. The first part is about setting up incident management practice itself. And the second part is a scenario-based incident resolution and postmortem. So let's start with the principles and practices. So what is incident management? It's a systemic approach to handling production issues. Whereby you can establish a standardized process across the organization so that when an incident hits, nobody's looking for what is the process, whom to inform, how to log these things, what to capture. Because we will standardize everything so that there is no cognitive effort put into understanding or the incident management process within the organization. It definitely don't cover how to troubleshoot. That is the part left to the engineers who will work on it. But of course, incident management stipulates that you should have um, run books and troubleshooting steps, and as much as possible documentation. Now, the incident management itself ensures the root cause is analyzed and recorded properly, and it also ensures that the postmortem or the analysis is blameless, because ultimately it's not the people but the process and the technologies that has to be fixed. Now, when you start setting up incident management for an organization, there will, of course, be some sort of basic process probably. But this checklist will help you to establish a proper foundation. Let us go through the list. First one is, of course, basic observability. Um for at least, you should have basic observability maturity of component level matrices, some matrices about the global business and your user traffic, and a bit of at least some amount of local logging for the sub components. The reason for saying that basic observability is required is that without this, your incident management or SRE teams are flying blind. They don't have a way to find out what is going on in the infra, whether the users are happy or they are affected. At this point, they will be dependent on human reports from customer care, a peer engineering team, social reports, or whatnot. Right? So that's a very, very bad situation to be in. That's why you should have a basic observability sorted out. The second one, list of critical functions of business. So every business, every application has some critical user journeys, which they consider the core of their business. Some of their features, some of the functions that they do. For example, think about accepting payments, right? If your payments are down, everything is down, or your business doesn't run. So things like that. So you need to have a list of critical functions of business. After which you should also have a list of software applications or service or components, whatever you want to call them. Essentially, for supporting your business is your software infrastructure, where you will have microservices, databases, message queues, and whatnot. So you should have a list of what are these components and who owns them. The other thing is, if you have teams, different teams handling different software stacks, they should all have on-call calendars and then on-call rotation. with an escalation matrix where if things doesn't work, you should be able to escalate to the management chain. The fifth one is categorizing the services based on criticality. Now, you can do it in different ways, but here we are putting them as different tiers. Tier 0 is the most critical one. This will be the foundational services usually. So networks, infrastructure, DNS, even some part of your application infra will come into this. And let's say in this example, tier 1 is payment. The reason again, payment is very critical, but the reason for putting it in or the other services to put it in tier 1 is without the tier 0 services, none of this would work to begin with, right? So we are just putting it that way, but ensure that your critical services are in one of these tier 0, tier 1, or tier 2 service, categories. This will help you later on. Now, alerting on critical matters of services from the top tiers. So we just talked about the tiers of the classification of your services, right? Now, once once you identify these critical services, you should have certain metrics which you identify as the critical matrices, and you should have proper alerting on them. For let's say whatever is the whatever issues are critical to them, you should be able to get an alert. And you should also have some global matrices, right? Customer traffic, payment, sign up. These are the signs of whether your application business are going good or your users are happy. So have a few of those matrices as well. Now, we talked about alerts, right? So all alerts should be actionable. There shouldn't be an alert without action, just for reporting purpose, because it doesn't serve any purpose and it just exhaust your on call. So don't do it. And of course, the importance of communication tools, tickets, issue trackers, chat and video for calls for coordination, wiki documentation services. Then at the last, run books, which are step-by-step instruction to fix issues based on standard alerts. Now we talked about incident, we touched upon incident classification. All right. So incident classification is the reason for having an incident classification is to see that there will be a lot of issues that everybody, each and every person would consider as incidents. What is incident for you and what is incident for somebody else might differ, and the severity also would differ based on who owns the incident, what happened, which parties are affected. So to standardize that, and level that playing field, we need to have a centralized incident classification, and you should define severity levels for incidents. So typically, Sev 0 is the most critical one, and then the numbers will climb up to Sev 1, Sev 2, Sev 3, Sev 4, depending on how many categories you want to hold. In some companies, there is no Sev 0; it starts with Sev 1. Pick pick whatever makes sense for you, but you should have this classification. And we talked about the criticality, right? So the criticality has no universal definition. What is important to your organization, business, and your users might differ from another company. So that is your foundation to decide what is critical for you. Now remember that list of critical business functions from the checklist, right? So this will be helpful in deciding what is most critical for you. And criticality is proportional to how wide and damaging is the business or the business impact. So that is how you decide what is what things to place in Sev 0, Sev 1, Sev 2 categories. And usually Sev 0 and Sev 1s are considered major incident because that has the most damaging effect in your business. So Sev 0s are usually catastrophic to the business. Something like data breaches, very heavy revenue loss, reputation loss, etc. Sev 1s are partial or complete outage of one or more products or services. It may not bring down your entire service, but your functionalities are severely degraded. Thing let's say there is some impact that impacts a considerable portion of your users from a particular geographical area. Let's say the entire Canada user base is affected, something like that. But rest of the world is working fine. So it could be a someone. So think of it and classify your incidents based on your business and your needs. Now, the incident management itself has a life cycle. It starts with detection. Now, detection happens in different ways. The most obvious way is that you get an alert about a critical issue, and then you start with the whole incident management. The other is you will get user reports either through social media or through your support services or some of your engineering teams who are aware that something has gone wrong. And once you detect, you will start looking at and exploring whether, this is actionable alert, what happened for a very short time. And then you will determine that, okay, there is an actual incident, at which point you will get to the second phase where logging and communication happens. Logging in this context means you have to create some sort of a documentation about, okay, there's an incident, what is the fundamental things that has happened so far. And if you have a ticketing system, you will use that for logging. And you also have to communicate to your peers, to your management. And if it is a wide impact, you probably have to work with your corporate communication team to talk to your customers as well. And again, this communication is something that will keep on happening during the period of your incident. If you have a long incident that impacts a lot of customers, you will probably have to put out public announcements, uh, Twitter messages, or other things. Also, as the severity and the impact continues, you will have to escalate these things up your management chain so that your leadership is aware of what is going on. Okay, so logging and communication is a continued process, but it starts from after you detect an issue and establish that there is an incident going on. Then, of course, along with this closely associated with the logging and communication, you have to classify, as we discussed earlier, you have to classify what severity this is, and then you have to prioritize. Now, why do you need to prioritize along with the classifying the criticality? Uh, let's say you have multiple incidents going on. You already have sub-zero going on, and you have another sub-1 coming in. And from what it looks like, you figure out that this sub-1 is an after effect of your sub-zero. And the moment the sub-zero resolves, the sub-1 also will get resolved. So in these cases, you will have to prioritize which one you want to fight first. And then, of course, you have to start diagnosing the issue, continuously figure out what is happening, work with people, then diagnose and resolve the incident. At which point we will consider the incident as resolved or stable, depending on the situation. And once this is completely resolved, you have to get into the phase of post-incident analysis, where we will look at what went down and what can be done in the future. Now, with the last life cycle stage was post-incident analysis, and let's talk a little bit about that. So, post-incident analysis is also known as root cause analysis or RCA, but it's also called postmortem. Now, the idea of a postmortem or an RCA is to learn from the incident. So you have to look at why it happened and how it happened. And the root cause is essentially what caused the whole incident. So you have to figure that out, understand what all went wrong, and you also need to establish a timeline of the incident. So with all these things, you will be able to figure out, okay, what went wrong and what can be done better next time, or how we could have fixed this or avoided this. Now, incident-related artifacts. So when an incident happens, it is very important to collect evidence of what all things went down. Now, this could include your metrics, dashboards, PR, git commits, alerts, bugs. Whatever helps in contextualizing the incident should be captured and kept. It doesn't have to be formalized at that point in time, but along with solving the incident, you should also keep capturing all these artifacts so that it can be used in later analysis. At the end of this analysis, you should capture all these things in a document so that the RCA document kind of becomes a living document that will help in looking at this from from leadership perspective, engineer perspective, and make sure that we learn from the incident. Right. Now, these are a few core elements that should be in your RCA document. There could be more than this, but these are kind of the foundation. First, obviously, is title, where you give one-line description of what was the issue, and if you have used a ticket or a bug to log this incident, let's say a Jira ticket, you should add that ID as well here in the title. Date and time, you should record the start and end time of the incident and the duration of the incident. Authors, the engineers who will be writing this document, typically these are the lead engineers who handle the incident and took it to the resolution. Now the status, we usually get into the RCA only after the incident is resolved. So typically the incident status would be resolved or resolved and RCA pending. Now summary. Summary is again like a bit more expanded version of the incident with numbers, like how much time it took, what all things were affected, what kind of features were affected, etc. And impact. And this is the detailed description of impact to the business, users, or systems. Think of it like you know all users from India was affected, or 20% of revenue was dropped. Replication, the critical replication, Kafka replication was impacted by lagged by 2 hours, things like that. Now, root cause. So it will be one or more causes that contributed to the impact. And along with that, you should put some categories, root cause categories or subcategories, so that it becomes easier for you to retrospect on this later. For example, there could be configuration errors, network outages. So these are kind of like categories under which you can. There could be more than one category for like an incident, but add this category so that at a later point you can look at all your incidents and see if there is a theme emerging, or there is one or two categories which has a lot more incidents than other categories. Continuing, trigger. So what triggered the outage with the cascading effect of damaging a lot of things? It could be just like network switch going down, or just a commit getting pushed to bad commit getting pushed to production, something like that. Resolution. Resolution is the some steps you took to mitigate the impact of this incident. Detection. How did you detect that there was an issue in the first place? Typically, this will come either from your observability or a human reporting. Now, action items. Right? Action items are a list of actions that you have taken or will take to ensure that the incident with similar root cause is not repeated. It would be like, consider like your MySQL server had an issue and you didn't have a failover mechanism, or you don't have a slave which you could promote as master. So ensuring that MySQL is not a single point of failure is an action item. Let's say the bad code went in without testing. Adding unit testing to that particular piece of the code is an action item. Things like that. Lesson learned. What went well, what went wrong, and what can be improved. Self-explanatory, but it's about like this pretty much like your sprint retrospective as well. What went well during the incident? Did people coordinate well? Did you have all the information that you required? Or was there any data missing, or was your remediation steps not working, things like that. Timeline. This is more like time-stamped account of all the important events. When you receive the alert, when did you find out certain thing was not working, when did other team X or team Y join the incident, who resolved it, things like that. Support info. If you remember the one of the previous slides, there was incident related artifacts, right? Capturing all those things and adding that to this document gives a lot more context about the entire incident and root cause to us. So keep this ready. Now, once we establish the process, right, there are some key performance indicators typically used in incident management world. We will start with MTTD. MTT essentially means mean time to something. So this is an average of across multiple incidents. So you will let's take MTTD, right? It's the mean time to detect. So essentially, let's avoid mean and let's say TTD, time to detect. How much time during an incident, how much time it took for you to identify there was an issue, right? This detection usually comes with an alert. So the issue, the moment the issue manifested or started versus the time when your alert, you received an alert indicating that problem, that is your TTD. And when you have multiple incidents and you average them out, it becomes MTTD. Next one is MTTA. It is the average amount of time between an alert and an engineer acknowledging the issue. So after the MTTD is finished, you receive the alert, and then somebody is looking at it, or like somebody got that alert, right? But somebody has to start actually working on it. So between that time that alert was sent or received So somebody start working on it is the MTTA. MTTR obviously is like, from the time, the incident started to resolving the incident, how much time it took, that is the time to resolve. Again, MTTR is the mean time to resolve. MTBF is it's not a unlike the other matrices, it is mean time between failures. Now, this is for a particular component or service. If it keep having incidents between two of those incidents, what is the delta? And you look at different deltas like that to see whether things are worsening or improving. That is mean time between failures, MTBF. Now, these are four key matrices that can give you an idea about how well your IM process is going, how your incident management in general is happening. But don't just depend on these matrices. You also need to have a good grip on how things are happening. These metrics themselves can be shallow at times. So don't fall into the blindly believing that okay, my MTTA is better, MTT is better, everything is well and good. It may not be. So for that, that is why you need to have this RCA reviews with more people, things like that. All right, that is about the theoretical foundation for you. Now we are off to the workshop. So this is the worksheet link. You can use the link or use the QR code to open it. All right. So as I mentioned earlier, we are going to talk about a scenario, and then we have two parts of question. All right. Now this is the background that we have set for this workshop. So you are necessary for an e-commerce company that has customers across the globe. Now assume that you have a basic maturity in observability and implemented component level observability with metrics and some logging. You also have basic alert management. If you remember from the checklist, you should have basic observability sorted, and you have it sorted here. Now, you don't have a dedicated incident management team, but you have a centralized SRE team which looks into it. So they becomes kind of like the folks who create the incidents, manage the incidents, as well as probably troubleshoot the incident in the beginning. Now, this is the high-level architecture diagram of the e-commerce application. Here again, we haven't given specific technologies or components, but rather this is more about high-level software domains, like a category of service or business function. This is just to give you an overall view, and we will start with that. If you look at each of these components, these are this group of services serves a particular category of function, and within this there will be a bunch of microservices, load balancers, proxies, APIs, whatnot, like all sort of stateful and stateless systems will be there in each of these domains. Now, typically, these domains or the components will be owned by one or more teams or business units, depending on how big your organization is, small your or how small your organization is, depending on that. But the point is, ultimately, these domains or components will have the right owners, and that ownership has to be established so that your IAM process is quite smooth, and that is the case here. Okay. Now, let's look at the first part of the exercise. All right, our first part is to set up incident management process for this company. Of course, we mentioned that we have basic observability, so that is sorted. And we will look at each of these checklists that we covered earlier and how it is going to be applied here. And for each of these categories, we have put one or two examples in each category so that you get some mental idea about what should be added here. But once you get that idea, use your imagination, look at the context of an e-commerce company, and keep adding some more entries here. So look at this. We are talking about critical functions of business, right? One of these functions is check out a chosen product that is already added to the shopping cart. So this is very foundational to an e-commerce product, right? You have already added something to the cart, and you should be able to check out the product. Again, we have put like primary domain as checkout, other domains that this feature, this function depends on our inventory, payment, etc. And the owner of this function essentially is cart and checkout team. It could be a BU, it could be a team. So keep adding like more functions to this. Then the component or service list. Again, this was in the checklist. Um, Look at the component name. Internally, for almost all services, there will be a name. So use that name. It should be, kind of a unique name within the organization. So these two elements are optional, but it is good for you to get a context of the service. And then, of course, you have to add who is the owner for this particular service. So in a lot of companies, there is software catalogs or software registries that will hold this kind of information. If it is not there, start by making one of these lists. And for every team, you should have an on-call calendar and an escalation matrix. Typically, your alert service or whatever software or service you use for alerting itself will have some sort of on-call alert management system. If it is not there, or even if it is there, go about having some sort of an on-call calendar like this. Typically, on-calls are per week. If you have just one team per service, it is just going to be just one on-call. All right, per week, one person will take the on-call. But let us say if you have a follow the sun model, like you have 2 or 3 teams across the globe who will take on-calls during their daytime, then you will have shifts within this. So let's say week of 17th June, you will have 3 shifts, and each of the shifts will have different on-calls per week. So depending on however you organize your team, create weekly on-call schedules, and for each team you should have an escalation matrix where whoever is your management chain, you should have them added into this escalation matrix. So this is just a sample. So first level escalation after the let's say John Doe was your on call and something didn't work out. John Doe has been troubleshooting, and at some point you will have to escalate this to his manager. So Adam, gets the escalation. Then probably Jacob gets it as a senior manager. Like that it goes. The other thing is categorizing service into tiers. If you remember tier 0, tier 1, things like that. Here I have put a sample. Kubernetes as a service is tier 0 because it's a foundational computer service. So that is one. Payment obviously is in tier 0. Shipping can wait. Once you take the order, if shipping has some delay, it still can be managed or adjusted somehow. We will put it in tier 1. So again, depending on your thought process, add them to the tier. You could actually add this as part of this component service list itself. Just add tier here. You should be sorted. So it's in a classification. This is the last thing. Now we talked about having different severities based on the criticality of the incident, right? So again, let's say some of the examples for Sub-Zero incidents. Unable to check out products that are added to the cart already. If you remember, right, this is how we describe the critical function of the business in an earlier table. So it gets impacted. This is Sub-Zero. Data corruption impacting all users from a big geographical area. Let's say every user in Canada, their data is kind of got corrupted. That's quite big one, reputation wise and technical impact wise. That's a Sub-Zero. Now a couple of save ones. User sign up is not working, but you're already signed in users or even or any registered user is not impacted. So comparatively lower, but it still could be a problem for reputation. And of course, it will impact your customer acquisition as well, right? Now, credit card payment not working for only one bank. So if it is working for nobody, it's a bigger problem because you are using all the money for that time. But given that it is one bank, it is still critical because you are losing money, but it could be considered as a server. So this is the first part of the workshop. So use your imagination again, contextualize with an e-commerce company, whatever you know about an e-commerce company, and use your experience as an SRE or as an engineer, and keep adding data into these tables. Now let us get back to the this talk and look at the part 2 of the workshop. So as I mentioned earlier, right, this is a scenario-based incident resolution and RCA. Now, again, go through then if you have any doubts, first go through the slides and go through the README, and then look at this problem and go about solving it. Okay, so let us start with the scenario. So again, this is an e-commerce company and it's facing a business disruption on a busy business day. It's not like a weekend or an off day, peak business time. And you get the following alert. Critical average number of checkouts are down by 7% in last 1 hour. Now, as an SRE, you know a few things about this alert. Okay. See, the average number of checkout is a global metric. It's tracked at the company level. And of course, like, it's, checkout is a critical business function, right? That is what makes you money. So, and this metric is emitted by the service called Checkout Backend API service. That much you know. And the other thing you have to look at is there anything unusual about the overall traffic now? Now, the checkout has dipped. It could happen either because, like, the traffic itself has dipped for some reason. Checkout is not receiving the traffic. That could be one. The other reason is there is too much traffic and your systems are not able to cope. So to know that, the first thing you would do is go and look at, let's say, your load balancer metrics to figure out, okay, is there too much traffic? Or you look at your upstream service to figure out whether they are getting the right traffic. And what you're seeing is that, like, the traffic has not deviated much from the same time frame from the previous day. So this is normal traffic. Nothing has changed. So the first thing obviously you have to look at is the checkout backend service, and it has a bunch of metrics on common HTTP error codes. So, and you see that one of these metrics is like this: checkout backend API HTTP 5xs. So this is the 5xs error codes of HTTP, and what you're seeing is the 503 errors have skyrocketed from 2 o'clock. Now, so the alert is valid. It's not a false alarm. You actually have problems here. All right. Now you start investigating further into this service and you look at the logs of the service and you find this issue. Get inventory code failed, received HTTP 500 from the inventory API. Now this indicates that, like, there is a real problem now. You saw the graph that, the 5xs are skyrocketed, and now you see in the logs that, some other service is causing this problem, right? Now you'll be tempted to, like, go further and, start investigating. Of course, that is what you want to do, but take a small pause. So it is confirmed that, there is a real incident going on, and before continuing the investigation, you need to declare this as an incident and log it. So just open up your, Jira ticketing system or whatever system you have, and create an entity. Incident XYZ, checkouts are down by 7%, and add whatever information you can. And you also need to communicate about this issue to your leadership and your peers, and in some cases, even to your customers. So you need to figure that out. And given that this is, like, deviating from your primary responsibility of resolving the incident, you can enlist other people's help, in this case, if it's possible. So what are our first, few exercises? Open a ticket in the incident management queue. As we discussed, like, if you are using Jira or whatever, you use whatever you have. Even a plain document would do. And you add minimum, you should add a title and a summary, what kind of severity, if you can, classify this. Then look at, like, time to detect, time to acknowledge, things like that, and add any relevant details that you can. Then, of course, communicate to the leadership. You have to tell the leadership, look, or your, management that, okay, look, something is going on. This is a potential, like, save 0 or save 1, whatever you have classified it, and gives them some, like, basic details so that, they know that, okay, something is going on. It doesn't have to be very verbose, just enough details. Okay. And once with that, that's done, your investigation continues. So we established, or, like, we saw that in the logs, the issue that checkout is having, it is pointing to an inventory error, right? And the checkout API has a very hard dependency on the inventory to place the order. What you're seeing is a partial architecture diagram that involves checkout and inventory. And from what you see here, checkout has to talk to inventory API, and inventory API is dependent on a Redis cache and then MySQL database, right? So the inventory data is stored in the MySQL DB, but to make sure that, to speed up the queries, there's a cache layer of Redis, which is what inventory API will first consult, and then if the cache misses, then the API will talk to the MySQL DB to figure out the inventory. Now, of course, we know that the next culprit or the next point of investigation is inventory service. So you look at the 5xx service or like the HTTP error codes of this service, and as expected, you find that the 500 errors have gone down around at the same time. The numbers are a little different, but the pattern is the same. So now you know that there is some correlation here. You go to the inventory API logs, and it shows this message is in high frequency, lost connection to server during query. So this is a very common error for MySQL, and you understand that there is some sort of a MySQL issue, right? So you pick up MySQL matrix dashboard and find one of these matrices, which is active MySQL connections. So around before the incident time, it was kind of stable, and then it started climbing slowly and steadily. It climbed, and it kind of peaked at 300, went down a little bit, and then again hit 300, but it didn't go further than that. So that is where the MySQL connections are right now. Now, given that Redis by architecture, Redis is supposed to take a lot of load off MySQL, the next thing we have to investigate is, again, you should be able to look at other metrics from MySQL itself to see whether MySQL has an issue. But you obviously see that it's taking a lot more connections, which means Redis is not doing what it is supposed to do, most probably, right? So you look at the Redis matrices, and one of the things that you see is cache hit. So cache hit means, if it is high number of cache hit, that means Redis is working optimally. And if it is going down, that means cache, the cache is not, it's not hot enough. And what you're seeing here is around the same impact time, the cache hits have started dropping, and it kind of went down up to, see, it dropped by roughly 2/3, and kind of is stable here and slowly going up and down, right? There's a huge drop, and then kind of it stayed at some level, right? That is where the cache hit is, which means it's sending a lot more requests to MySQL. Now you look at the server uptime for Redis cluster, or there are three servers basically. As you can see, 192.168.1.101, 2.101, 2.102. And out of that, 2.101 and 2.102 had a downtime around this time. This graph will be a bit skewed because we are only looking at 30 minutes of time, but it went down around this time, and of course it came back up as well, right? So it's not like it has been down forever. It came back up, but things have not changed. Around this time, it went down, and the cache hit is still low, so nothing has improved after that. So now we have to find the root cause, right? We have gone, in a reasonable amount of background, and debugging information to go on for, finding the root cause. We have pointed to where exactly the issues could be, and now you have to use your experience as an SRE and think about an e-commerce application and make reasonable assumptions about the overall architecture and find the root cause of the problem. All right. And once you figure out the root cause, you have to find out what are the remediation steps and fix the problem. And once you fix it, the incident is resolved, and you have to communicate that also to the leadership. Again, right, like another communication to the leadership. And once all this is done, you have to do a root cause analysis and write a postmortem report with this format. So that is the end of this second part of this workshop. So see, a lot of details about the infrastructure and incident in this problem is kind of left to your reasonable and logical guesswork. The reason is there's enough for you to go on here, but you also should use your imagination to figure out, okay, what could happen. And depending on how you think about it, you might arrive at a slightly different answers. And that is what would make this problem interesting. And it also helps you in figuring out, okay, what are the different action items if scenarios were like this, and versus something else, right? So thanks a lot for listening. Go through the slides again, read the problems again, and start working on them. And thank you for listening, and all the very best.